Alright, welcome to ArmanisMath. Today we're going to focus on solving absolute value equations and inequalities. How to solve absolute value equations and inequalities is going to be the topic of the day. I'm going to jump right into the objective. The objective is I will be able to solve absolute value equations and inequalities. So I'm gonna again cut through the chase in this short lesson by giving you the big picture first. Okay, hopefully that you're taking notes, which it's gonna benefit you. So I'm gonna give you the big picture first. When we say absolute value, we're talking about distance from 0. Okay, so if I said absolute value of x equals, let's say, 2. This means I am, if this is 0, this is where I live, it's 2 miles away this way, or 2 miles away that way from where I live. Okay, so it's 2 miles this way or that way. It's either -2 is the location or 2 is the location. So keep in mind that when you talk about the absolute value, you're talking about distance from 0. Okay, distance from 0 for real numbers. And again, back to the big picture here before I launch to the lesson. Is this actually used in real life? The answer is yes. For example, geophysicists use absolute value to look at the total amount of energy used. In an energy wave, there are both negative and positive directions of movements. So that's why the absolute value function is used in that connotation, as well as some other ways as well. If you could think of another example, you could share it with us in the chat or also on the comment on the video when you watch afterwards. So I'm going to again start with the big picture of that before I actually launch that lesson. And it's going to be like this. Today we're going to talk about the absolute value in different formats. So for example, today we're going to talk about the absolute value equals a number. Talking about the absolute value is less than a number. The absolute value is greater than a number. And all these are different cases for the absolute value. They're not the same. By the way, when I say greater than, this also could mean greater than or equal to, or less than or equal to, greater than or equal to. Okay, so keep that in mind. So there are actually, you could look here that we're talking about 3 different scenarios for the absolute value. So again, back to the big picture. If I'm doing these, if I'm solving these for the absolute value, I'm going to split them in 3 different categories. Either the absolute value is going to be equal to a number. And pay attention, because this one is absolute value is less than a number. And this one down here is the absolute value, again, greater than a number. Number. Let's take a little bit closer here. Let's zoom in a little bit for the absolute value is equal to a number. To solve this kind of problem, you have to split. There's 2 different cases here. One case is that x will be equals to whatever inside the absolute value is going to be equal to the negative of that number. Be careful when you write this notes. There's a negative here, negative before that number. See that? Or the absolute value equals to the positive, equals the positive value of that number. 2 cases here. Or. Okay? 2 cases. The absolute value of x less than a number, this case is called the bounded. You're bound between 2 numbers. So your x actually is going to be whatever inside here, whatever inside the absolute value is going to be bound between 2 numbers. Either the negative of whatever number that you're talking about here, or the positive of that number. So one more time. When you talk about the absolute value, case number 1, what's equal to a number, you split. Either you equal to the negative number or the positive of that same number. If you are less than that number, or less than or equal to, you're bound between, you actually bound in this case, you are in between the negative and the positive of the number. Lastly, is if you have a if you have an absolute value that is greater than the number. This is going to be a unique case here. You're going to split, but you're going to be very careful when you split. This is going to be x is less than the negative of the number, and x is greater than the positive of that number. And obviously, we're going to talk about these in details, okay? That's just a big picture here. So today, in today's lecture, we're going to talk about the absolute value in its 3 cases, one of which is when it's equal to a number, less than, and then greater than of a number. Okay, this first simple thing here is if the absolute value of x equals to a being a real number, then x equals either negative a or x equals a. It's not and, it's an or. X either equals negative a or a. Here's an example here. Solve says the absolute value equals 5. Well, think again. You're saying you're 5 miles away, and you could be 5 miles away to the right or to the left. That's why you have, it could be to the left, which is x equals negative 5, or it could be to the right side, which x equals 5. So let's grow up a little bit and do a little bit more, just a little bit more development in this concept here. So I'm trying to hide my solution here from you, so don't look at that yet. Okay, close your eyes. Here we go. I'm gonna say this is x plus 2 equals 5. Well, again, because this is the absolute value, you've got to split. If the absolute value equals, you got to split. So how do I split this? Well, you're going to say what's inside the absolute value equals 5 or negative 5, or what's inside the absolute value equals 5, either the positive or the negative of it. That's exactly what I've done here. You're going to say x, what's inside the absolute value. By the way, a common mistake for students, some of them put the absolute value back here when they solve. That is, please do not do that, because once you split, the absolute value bars are gone. They're dissipating. They disappear. So here's maybe a mental picture to help with that. Is if you are splitting, this guy's gonna go away. This bar, protecting bar, is gonna disappear, leaving you only with what's inside the absolute value. So what's inside is x plus 2 equals negative 5, or x plus 2 equals 5. And if you kept on going, you're going to find yourself you're adding 2 to both sides, subtracting, I should say, 2 to both sides, and end up with negative 7 and 3. That's 2 different cases for the absolute value here. Okay. Obviously, now you are ready for a little bit more of that. So I'm going to just spice up things a little bit, okay? Not too much. Does anybody here like spices? Spicy food? Hot spices. I love it. Love hot spices. Okay, let's do this example here. I have this example for us, and this one is going to go on a nice looking page. Ooh, look at that. Love this. Okay, what if we have this example here? This one, again, says solve the absolute value of 2x plus 3 equals 4. Remember, you always want to isolate the absolute value box. It's like, think of it if there's a gift box you have. Somebody's giving you a gift box, and you're unwrapping the gift box. Okay? So basically what you need to do is get rid of things that are outer wrapping for that Xbox. Okay. I need to know what's going on in the chat. What's going on? Does anybody have a question in the chat? Kayla? Oh, thank you for explaining that, Abby. Okay, guys. So if you have a question, do write it in the chat, okay? I've got to, so in this case, I've got a split. So as we do a split, you will lose the protective bars for the absolute value. So this one is going to give you 2x. I will, by the way, post this video. So in case of you see me a little bit speeding up, I'm not doing it on purpose, but you will have the video posted hopefully by the end of the day. Okay, this is 2x plus 3 equals the 4. Okay, because it's equal to, I'm gonna split, and when you split, you get rid of the absolute value bars. So in this case, what do you think I'm gonna do to solve for x? You're welcome, Gilles. Yep, I'm gonna subtract 3. Subtract 3. Do this with me. Don't wait for me to solve it. Do it with me. Let's make mistakes. Let's fix our mistakes. Let's learn. So I've got 2x equals negative 7. Divide by 2. X equals negative 7 over 2. So that's one proposed solution, right? That's one proposed solution. The other one is 2x equals 1 divided by 2, x equals 1/2. So that's also another proposed solution. Remember, we said the word or is either this or that. There's an or here. So that's what you do when you have absolute value equals to a number. You split in two different cases. One is negative of that number, one is positive of the number. Remember, what you're saying is what's inside the gift box is equal to that amount, okay? Don't forget that. And let's go into a little bit more spicy stuff, okay? Let's go spices. Spices. Ay, ay, ay. Okay, we're gonna go spicy now. Let's do another spicy one. By the way, do you remember PEMDAS? You also could go backwards in PEMDAS. When you're unwrapping things, you could go backwards in PEMDAS. So let's say I'm gonna solve again, and I have the absolute value of 2. Oh, hold on a second. That was outside the absolute value. No momento here. I've got 2 minus 7 absolute value of x plus 4 equals negative 12. Okay. Well, there are some shells here. There are some layers. There are some gift wrappings that I have to unwrap first. So first thing first, what do you think I should do? Can I touch the 7? No, I cannot touch the 7. 7 is multiplied by the box. You can't do that first. First of all, you have to get rid of that 2. So I need to get rid of that 2. My little Levi, he turned 2. So ask him, how old are you? He says, I'm 2. Oh, so cute. I'm 2. Get rid of the 2. Okay, when you get rid of the 2, I'm going to end up with negative 7 x plus 4 equals negative 14. Okay, well, I'm not interested in negative 7 of my box of the gift. I'm just wanted my box by itself. So in this case, what are you going to do? What are you think you're going to do? Here we go. I think Delaney is trying to tell me something. And Jaren is also, yep, that is it. Divide by that, you're going to end up with x plus 4 equals 2. I'm 2. How old are you, Levi? I'm 2. Okay. Now you're going to split. Now we're going to split. X plus 4 equals the negative 2. And x plus 4 equals the positive 2. So I'm going to subtract x from both sides. Subtract, I should say, negative 4 in this case for both sides. So that's a negative 6. That is one proposed solution. Oh, that's a awkward software movement here. So it's not me trying to be sloppy. It's not me. And this one is going to also negative that, so it's going to x equals to -2. Okay, here we go. Two proposed solutions. Remember the word or. This one or that one. Give me a thumbs up if we're good. Thumbs up if we're doing good. Okay, I like that. If you wanted me to, here we go. Quite a few thumbs up here. Okay, now let's move on to the second item. The second item is when the absolute value. Actually, why don't you practice? Do you want to practice one more? Who wants to practice one more on inequality? Okay, here we go. Let's practice this one here. Don't look at my solution, okay? Don't look at my solution. Hold on. Hold your eyes. Close your eyes. Close your eyes. Okay, start. Go at it and see what you could do here. Let's see who's gonna be the first to show the whiteboard. Okay, I see a lot of answers here. Let me examine some of them here. Delaney, I see that. Jaren, yep. And Layla. And Macy, I see that. Good job. Peyton, I see that. Salma, awesome job there, Salma. And I've got Sarah. And I've got Stephanie. That's great. Good job, guys. Okay, so this one will give you either the -2 or the -2. Is it -2 or -3? I might have a mistake here. What do you think? Show again, Sarah. So you're saying 3. So basically I have 2x plus 3 equals -9. And then I subtract 3. -9 minus 3 is -12. Divide that by 2 is -6. And I've got 3 subtracted. That's 6 divided by x is going to give you 3. All right. Let's move on to the second item. And this one is going to be the inequality, basically, is what we're going to do. If you see any green or teal background like this one, this is it's taken from your textbook. So I will just copy, obviously. Hold on, this software is not behaving here. I will definitely take time for it to copy it from your textbook, not from here. But in a nutshell, this is what they're talking about. They're talking about this. And first example we're going to take is actually going to be the less than concept. Okay, so once again I'm going to just review this very quickly here. If you're saying your x is the absolute value of x is less than 2, remember you're saying what you're saying is the distance is less than 2 in both sides. So if you're here, you live here, maybe on let's say whatever, McHenry, and this is 2 miles away from you here, and 2 miles away from you here. You're not sure where's your next In-N-Out. Is that your favorite place, you guys, to eat out? Can you put that in the chat? What's your favorite place to eat, dine out, or just... Okay, I'll take that. I'll take In-N-Out. So you're saying, I don't know, Mom. It looks like I know there is an In-N-Out this side of the house or this side of the house on McHenry, but I'm not sure. Is it 1 mile, 1 mile and a half, up to 2 miles? But it has. I know, Mom. It's actually less than 2 miles. I'm not gonna drive. You could look at the odometer. I'm not gonna go over 2 miles. Please, I could go and pick it up. Okay. So if you're between 2 miles, it could be 1 mile this side or 1 mile this side. 1.5 miles this side, 1.5 miles that side. So basically you're bound between, your value is bound between here and there. And that's why for less than or less than equal to, you kind of basically put yourself in between these two values. So here's an example. If I said, for example, solve this here. Solve the absolute value. I'm going to go easy first. X plus 2 is less than 3. Okay, that's no problem. So I'm going to take what's inside the absolute value. Remember, what's inside is what's going to determine the solution to this inequality. I have to be greater than the negative amount of it and less than the positive amount of it. Is this the only way you do it, Armani? No, it's not. Is this the most easier? Is the really most explicit? You could see it with your eyes? Yes, it is. Obviously, if you're conversant with inequalities, you could do it in a different way. I could show you that towards the end, though. So in this case, now I have to subtract. If you want to just x, you got to subtract -2 from all these three sides. So I'm going to subtract 2, subtract 2, subtract 2. And if I'm careful, I'm going to end up with -5. And that is going to be less than the x, which is going to be less than the 1. So basically what you're saying here, you are here, and I'm reviewing for the test. You are here, and this is a 1, and this is a -5, and you're bound between these two numbers. That the In-N-Out that you're looking for is between these two directions, two addresses, -5 and 1, but does not include the 1. If you went at 2 miles, nope, you're gone. It's not gonna work. So that's why we have this number line representation. Can you give me this representation in interval notation? Interval notation. So this is number line. What would this look like in interval notation? Yep, I see that. -5, I see that, Abby, and then a 1. That's precisely what you do. It's not including -5 and 1. You also might try set builder notation, by the way. Raster, I would not do raster for this, because raster is gonna get you, yeah, raster would not be. The reason is because this is all real numbers here. And if you want to list all real numbers in raster, that's not gonna be possible. Yeah, because it's infinite amount of real numbers within these two. Okay. Somebody was asking, is there another way to do it? I'm hesitant to show you, but I'm gonna show you anyway. Yes, there is a different way, which is you focus on one side of this inequality at a time. So you probably wanna look at this here. Only this part. So you could say also x is, if you read this carefully from the variable, is greater than -5, and then you focus on the other side, which is this dude here. X is less than 1. So yes, there is a way to split them. Again, you just have to be conversant with a little bit conversant and careful with inequalities. I would stick with the format that I have here, but this is also another option. It's up to you. Okay. Let's see if we can spice up things a little bit, okay? We're gonna do another example that has some spices. Spices! 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 I have 6. Example 7. Hello. My cursor is acting up because I have a lot of them. Okay, let's take a look at this one here. Let's do this one here. X plus 3 is less than 5. X plus 3, oops. X plus 3 is less than 5. Macy, I see that. Go ahead, you guys, go the extra mile and give me interval notation as well. Let's just review for that test. Layla, I see that. Good job. Delaney, I see that. And Peyton, I see that as well. Good. Again, give me the interval notation as well. I see that, Macy. And Peyton, yes, you fixed it. Thank you. Good job. Yeah. Emily, a little bit up, Emily, so I can see. You disappeared. All right. So let me see what's going on with this problem. Well, because you're less than, that means you're bound between the two items. I see that now, Emily. You're bound between the two items. So I will have to bind. Oh, that's too big. X plus 3, that is. Okay, and then you subtract the 3 from all 3 sides, and you find yourself looking at -2 and 8, and interval notation would look like this. Okay, let's move on to the next item, which is the greater than. So the absolute value is greater than, and the concept is again very simple. The concept is very simple. If you have the absolute value greater than, let's say 3. So focus a little bit here with me, because now this one is going to be a little bit concealed, I could say, is this sneaky. So watch what this says here. You're saying that the absolute value is greater than 3. If you are at the 0 point here, what you're telling your parents or your siblings, I know there is an in and out, but it's 3 miles away from here. 3 miles away or more from here. And in this case, it's actually going to be 3 miles or more than 3 miles in this case. If you want to say 3 miles or more, you're going to put an equality here. So if that's what you're saying, you will have to drive 3 miles with nothing happening. There's no in and out here. And then once you get 3, you might find in and out here in this region here. In this, okay? But if you drive this side here, remember, you can't find in the first mile or 2 miles or 3 miles. There's nothing here. You will have to find it here on this side. So basically, you have more on the negative directions. You have more on the positive direction, but there is nothing in between, because you're telling us that the distance that you have to drive has to be 3 miles or more from where you're at. 3 miles or more means I have to go to the 3 miles mark and then start to look for in and out. Okay? Other directions. So in this case, I'm going to say x is less than or equal to -3. and that's the sneaky part of it. And on this side, it has to say x has to be greater than or equal to 3. It has to be more than 3 miles this way. And if you also wanted more of the negative, it has to be written in that format. Okay, let's take a look at an example. Let's say I've got myself a desire to go somewhere to pick up that delivery, or I mean from my parents or from my family or something. And now this one here says, well, you know what? Solve. Try to find this location. So you don't know. You know it's more than 3 miles away. I don't know where exactly is that location yet, but I know it's more than 3 miles either directions. If I'm right on McHenry, or left, south, or north of McHenry. So in this way, again, in this, I have to do what? I gotta split. Two cases here. Either x plus 2 has to be less than the negative value, or x plus 2 has to be greater than the value of that amount, greater than 3 miles. And if I do that carefully, I'm going to end up with negative 2 here subtracted. So that's a negative 5. X has to be less than negative 5. Or in this case, x has to be greater than, if we subtract 2, that's has to be greater than 1. So if I want to graph this on the number line, I'm going to look at these here. And let's see how would that go. The number line here. Whoa. And I'm going to have myself a 1 and a negative 5. Do I bubble or not bubble here? Do I bubble or not bubble? To bubble or not bubble? And that's the question. Let me see. Don't bubble. Don't bubble. Don't bubble. Okay, do I go right on the 1 or left on the 1? Yep, you are more than that, and you are less than that. Just like a rabbit ear antenna. Well, you probably did not see that in your life, but they used to have antennas, rabbit ear antennas they call them, for the TV. Okay, and go ahead and give me interval notation for this one. Be careful. Some of your other classes did not get that correct. Give me an interval notation for that one. How would you write that down, interval notation? I love that. That's very good, Abby. Good job, Abby. And Delaney. Yep. Now let me show. Actually, a couple of you have given me good looking answers here. I start all the way from infinity, negative, all the way to negative 5, and there's a union or. And then I have 1 all the way to infinity, and I'm not including either end points. Okay, interval notation. I want to point out one thing, that you also could look at this, believe it or not, you could look at this concept geometrically as well, in geometry. So let's see what that exactly means. You just gave us, Armani, f of x, absolute value of x, plus 2 equals 3. Okay? So this is the concept geometrically, okay? I could split this guy in half, meaning I could say y equals this side and y equals this side. So basically I've got two different functions here. So if I were to graph, if you guys remember the graph of the absolute value of x, does anybody remember that? You could use your you could use your hand gesture to show me what exactly does that look like. What's the graph of the absolute value look like? Come on, champions. The parent, yep, I see that, Jared, yep, it's a V shape. Here we go. So this is the parent, and it's a V shape, vertex at 0, 0. That's the parent. What do you think is happening here to this dude here, this child? Is it left or right, or? Is the child going left or right? Is it translating left or right? Is it shifting left or right? Slow down. Whenever you see anything next to the x, remember, anything with relation to the x, yeah, it's always the opposite direction. Don't forget that. It's always x. The h horizontal is always the opposite direction. It's actually going to the left units. So if I were to graph this, if I were to graph it, I'm going to have something like that, and something like this, where I could go to x negative 2, there's 1, and there's 2. I'm going to have my line like this, and my other line like that. Okay, now how do you graph y equals 3? How do you graph y equals 3? Y equals 3. Reviewing for the test. Y equals 3. What does that look like? Is this a horizontal line or a vertical line? What in the whole world is going on here? Thank you. I see that. And Macy, I can't tell. Oh, Delaney, that could mean a lot of things. If you are you like you're rotating? Yes, it's horizontal, and it's at 3. So if I were to do this one, obviously my graph is not to scale, but if I were to do this one as precise as I can from this side, I'm gonna look at this line here, and let's say that this guy is, hold on a second, I'm a little bit up here. Hold on, Mr. Armani. This software is not cooperating with you here. But hold on a second. Let's say I am somewhere here. And this is my y equals 3. That's a horizontal line, you guys. So what you're saying here, just pay attention for a second here. What you're saying, because you're saying you wanted to solve this, you basically wanted to find the point of intersection. Where do these functions meet, cross? Well, apparently in geometry they cross here. Basically they cross at this point. This is the intersection point. 2 points here. This point here, that's one of them. And at this point here, which happens to be, by the way, when you solve this -5 and 1. So this is the concept of it being resolved in geometric graph. This is how do you picture it in geometry. You could picture it also on the number line, as we said here earlier, an interval notation. All right. Let's do more. And this one's going to be pretty spicy. Get ready. Ooh, hot. Okay, let's do that. This one is going to go like this. Again, solve. And what I see here is 3 plus 2 times 4x minus 7 is greater than 13. Oh mama. Okay. What do you think I should do at the beginning? Shall we touch the 3 or the 2? Ethan says you should start with the 3, which is true. That's the wrapping that I could get rid of before the 2, because the 2 is connected in multiplication. So -3, -3. And if I'm careful with this, I'm going to end up with 2 times 4x minus 7 greater than 10. What do you think I should do? What's my next step? The next step is to divide by 2 according to Jiren and Maddie. Thank you. So I'm going to divide by 2. That's going to leave me with box, right? The x box greater than or equal to 5. Because it's 5 and it's greater than that amount, do you think I should split or include the value? Should I split or should I include it in between the values? I shall split. Thank you, Nicholas. I shall split. And this split, as I said, I gotta be careful because you're gonna have to split in the more negative direction and in the more positive direction, meaning whatever inside the absolute value will have to be less than the negative or more than the positive. Okay, and this, I'm gonna, somebody talk to me here. What do you think is my next step? Joseph, what do you think is gonna be my next step? Amador, what's gonna be my next step? Joseph, I already split. I can't split any longer. That's the most I could do. Come on, Joseph. Add 7. So if I added 7, I'm going to end up with 4x's less than, if you add 7 to this guy, that's going to be a 2. Divide by 4. Divide by 4. X has to be less than or equal to 1/2. Okay. And here, what do you think about here? This side here. This one is going to go for Carolina. Carolina. And Audrey. It's okay, Peyton. Carolina. Audrey. Remember what the short video was talking about, the integrity, and a lot of things that you do on your side, obviously, is you're not in a physical brick and mortar classroom where I see you. So when it comes to test or quiz or homework, remember that you're honest. You're building a character of integrity. It's your answers. It's you struggling with the problem. You are productively struggling to find the answer for the problem, not looking elsewhere, not looking at somebody's answers. Same thing here. If you are not able to connect, is it really you not being able to connect, or is it you not wanting to connect? So that's also another part of integrity. Macy, I see that. Looks good. I did ask a couple of you to answer Carolina and Audrey. Are you guys here? Audrey, you did add 7. Okay, she said add 7 to both sides. I'm going to add 7 to both sides. And this case is going to give me 4x is greater than 12. Split divided by 4. Divided by 4. I've got x is greater than or equal to 3. Okay, how do I graph that? Can you help me graph that in your whiteboard? Here's my... Wow, what a number line. That's a number wave. It's not a number line. 1/2. Got 3. Should I bubble or not bubble? To bubble or not bubble? And that's the question. Bubble, bubble, Armani, bubble, 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 bubble. On the 3, should I go right or left? Okay, Trace, I go to the right. How about the half, or the 1/2? Should I go right or left? I'm gonna go left. Okay, go ahead and do the extra step. Remember the extra mile? Go the extra mile. You're practicing. Do interval notation for this dude here. Okay, I see that. Thank you. That is going from all the way there to that, and or this one here. So hold on to your board, Peyton, for a second. So one of the proposed solutions is to go from negative infinity all the way to half, including the half union, or I also could start from the 3 going all the way to infinity, including the 3, but not infinity, obviously. Can't touch that. Can't hug infinity. Okay? That is this one over here. Tell me, how are you doing, guys? Are you on on task? Are you doing good? I see thumbs up there. I see are you getting this? Okay, good. All right, now let's move on to obviously you could use a private chat. You also could use your whiteboard to give me some other answers as well, like hey, I'm still struggling with this, can we do another one, please? Remember, you could use whiteboard as well. It's also another option. A lot of options for you guys here. Same thing with studying for the test. You have a lot of tools that you could at your disposal. Okay, let's move on to review for the test. Review for the test. Actually, I'm going to start a new page. Review for the test. Okay. First thing first, you need to study for this test, because once again, tests are 40%, and then quizzes are 30, homework classwork is 20, so it's gonna weigh more into your grade. I'm just trying to motivate you to study, by the way. That's all what I'm doing here. The second thing is the tools that are available for you to study are the videos that I post online, are also the homework that you've done, the quizzes, definitely the examples in the textbook. Okay, so now these are, you got a few tools at your disposal. You need to spend time this weekend before the test, so you can do well on that test. I'm going to start reviewing from, I'm not actually going to review as much as give you a list of potential problems that might show up. By no means this is going to be an exhaustive list of things that's going to show up. It's just going to be a sample of things, but you are responsible from P1 to P7, whatever we covered. So the first one is going to be the real numbers, right? Real numbers. So make sure that you identify the reals, number sets. The reals, the natural numbers. So make sure that you're aware of that. If not, then make sure there's a video on that. Make sure that you review that video. Interval notations. So we talked about interval notations, including set builder notation, X, such that X is Armani's student, for example. This is a set builder notation, since you do not list them as in roster notation. Roster is where you list. And also we talked about the interval notation, like the brackets and the parentheses and stuff, which we did review during this lesson. Exponents. Let's talk about exponents. So things like this. And for this, actually, I wanted you to try this with me here. So let's say I have a 3x squared y minus 2 divided by 6 x5 y3. How would you simplify this? Let me put the word simplify. How do you simplify this? Yep, Jalissa, you're right, yes. Okay, first of all, do I do anything about the 3 and 6? Yep, you do. How about the x to the second, x to the fifth? X second, x to the fifth. Can I simplify that? Okay, what do you think is going to be the answer? Go ahead and give me the x's as the answer. Do I end up with x at the bottom, x at the top? I know I have 2 at the bottom right now. X cubed at the bottom, according to Abby. Good job. And what do you think the y's? Good job there, Macy. Yes, y5 to the bottom. Why? Because this guy's not happy. This is not happy at all. You just move him to the bottom, where it becomes y3 times y2, which will give you y5. What's going to be at the top? What's left at the top? Do I have do I have a numerator? Yes, there is one. Okay, so that's one of them. Another also might show up is something like let's say 2x to the fifth y second divided by 3x negative 2, and this whole thing is raised to the third power. So do you want you might want to try this one. First of all, I'm not going to wait until you guys finish, but what's the main idea here? What do I need to do first? Does anybody remember? Does anybody remember what to do first? And don't forget PEMDAS or some iterations of it. I could do that, Abby, but I probably could. I mean, I could do it. There's nothing wrong with that. But would I be able to perhaps deal with what's inside the family first, family issues first? Exactly, I would fix what's inside first, since I've got x's here that could deal with that. That's probably the easiest way. But there's nothing wrong, Abby, also with distributing the 3. You just have to be a little bit careful with the negatives. Okay, moving on. We're going to talk about P2. And P2, there's a lot of ideas in P2. There is a video on P2 with a lot of thorough explanation. So first of all, you got to know the Cartesian plane. This is P2. Q1 I should say, Q2, Q3, and Q4. You know the location of these points. The absolute value we talked about extensively today. You know the cases: equals, less than, greater than. Also distance formula. So for example, find the distance. Let's say between 2, 5 and -3 and 9. Okay. Attached to that is the idea of the midpoint. Formula. You could look that up also. By the way, does the distance formula have a square root in it or not? I'm just curious. Oh, okay. Thank you. Thank you very much. And then we're going to talk about the equations of the line. Okay? Equations of line. Meaning, what if I give you a line? Let's say I give you y equals, y equals, let's say 2x plus 3. What's the slope here? Yep, I see that. So what's the slope of a line that is parallel to this guy? It has to be the same slope. Has to be the same slope. How about slope of a perpendicular line? Slope of perpendicular line. Yep, -1/2. That's awesome. So what if I asked you, find me, given this equation here, find the equation of the line, that is perpendicular to the given line here and passes through, let's say 2, 3. So does anybody recall what exactly is that formula is called? If I gave you these two indicated information here, I gave you a point here. I'll give you a point slope. That's it, point slope. You have a point and then you have a slope. Okay, and then equation of circles. Given circled, this is a math symbol for circle, centered at 2, let's say -3, and radius of 5. Find the equation. The equation of the circle. Okay, moving on. I am now on P3. P3 has how to solve equations, and also this has its own video. So one of which was solving inequalities, and I ended up with 3. If you guys remember, in that video there's a quantity of 3 different parts. Remember, there is something at the bottom where you have to find the least common denominator. Remember that? Okay. I multiply everybody by that amount. P4 is the lines in the point slope, and then equation of the line, slope intercept form, the whole thing about the slopes for P4 as well. Okay, slopes on lines. P5 is solving quadratics, and I have a video on that. There's 4 ways. Expect to see them. Quadratics. If you remember any one of them, you could put them in the chat. P6 is complex numbers, which you also have a video on, an awesome video. I spent a lot of time doing that video. Complex numbers. And one big thing about the complex numbers is, for example, how not to have i's in the denominator. So 2 plus 5 i's, let's say 3 minus 2 i's. This is not fine. This is not standard. The standard is not to have i's in the denominator. So you have to multiply by the conjugate. Does anybody can anybody give me the conjugate of this? Conjugate. 2 minus 5 i's. And obviously multiply top and bottom by that conjugate. Okay? I would use the box for this. Definitely use the box for the top, box for the bottom. If you do this correctly, you should not end up with any i's in the denominator, because that's why you're doing the conjugate. P7 is what we talked about today, more in depth of of the absolute value. Okay? Okay, best of luck to you. Spend time. Maybe you need to breathe pre-calc this weekend, or whatever you have to do. Spend time on this. And I'm expecting you to do very well, because you always do. Be honest and make sure that you study. And these are your actual answers, because you're learning for the future, not just for now. Any questions? I'm going to end the recording here.